Okay, before we get started, I want to take a quick minute to show you how to find the information you're looking for. And if you're trying to apply the same steps to different projects, you will need to know what to look for. So the first thing I do is search for the project itself. And if it's like an open source Arduino project, you will usually find a GitHub page. So this is actually the first thing that comes up here. So I open this, and this repository is where the code and just everything about this project lives, basically. And yeah, if you scroll down, you find the README file. This is it. And it contains a lot of info about the project. Now we are looking for a installation guide. So we scroll down, there it is. It actually tells us to click here to go into our wiki. And if we do that, here we are on the installation tutorial. We are looking for compiling using Arduino IDE. So I click here. For all of those that just look for a quick tutorial, these are the steps you need to follow. I will go over them in this video in a bit more detail to try to prevent a lot of common pitfalls. But yeah, you can just follow them as they are. So if this is a different project and you can't find any installation tutorial on the README itself, what I recommend you checking is whether or not there's a wiki tab in the top. Because some projects, like this one, they can be so big that it's not worth putting the entire documentation into the README file itself. So GitHub has this feature where you can host a little wiki page on the repository itself. You just need to know that it's there. And this is where you find, the documentation of this project. And in our case, we're looking for installation. So that's here on the right. And compiling using Arduino IDE in particular. So if you click there, we are on the same page again. So that's just a quick tip on finding these instructions. I'm also showing you this because the instructions might change in the future. So checking this out is always a good idea before you get started, because as projects evolve, they might require a different setup process. So yeah, this is how you find this information. And now let's get started. Okay, first of all, we need the Arduino IDE. So I look for Arduino. This is their homepage. And if we go to software, you will find the downloads for the Arduino IDE. That's what we need. And I will download the Windows 7 and newer option here because this is a Windows computer. Just download. All right, yeah, I agree. Yes, install everything. Okay, and then if it's done installing, we can close this. So if everything went right, we should be able to start Arduino. And as you can see, it is working. We have it open here. But what is missing is our code. We need to download the project so we can actually have something to compile and upload, of course. So I'm going back to my browser here, and I'm going back to the installation tutorial. And as you can see, step 1 is download the source code of this project. Now we can just click here and this will download a zip file containing the source code. Alternatively, you can go back to the main page of the repository and click on code and then download zip. Also, another option is to go to the releases here on the right and then go to the latest release. Then you will find all the bin files here, but you will also find the source code in a zip. So whatever you decide doing, you had just downloaded the ESP8266 Deauther V3, and I'm going to extract that, open the folder, go to the ESP8266 Deauther folder, and here we find the INO file. That's what we are looking for. The INO file is always the main file for an Arduino project. Okay, so this is the file we want to open, so I'm just going to double click it to open it with the Arduino IDE. So here we have it, and you can see there are a lot of tabs in the top here, and those are all the other files in the folder. So this project is pretty big, and I think this is a good time to point out a common pitfall. And that is, just having this INO file is not enough. You need the entire folder with all these other files. They are all required for this project. What will not work is if you go into the zip file, like this, go into the folder, go here, and then double click it. Let's see what happens. Okay, so I opened the same file, right? But all these other files are gone. They're not here. And that's because we just opened it from the zip file without actually extracting the other files. It only extracted this one file. So this will not work. You need to download the entire project and extract the folder, go in there, open it from here, so that you see all the other files required. If you see them, then everything should be good to go. So now we have Arduino installed and we have the project open in Arduino. So far so good. But how do we compile this now? Usually you would just click the verify button in the top left, but the problem is we don't have a compiler for our ESP8266 board. We need to install that as well. To see what boards are supported in your Arduino IDE, you can actually go to Tools, Board, and then select the one you're using. But with a clean Arduino installation, you will only see those classic Arduino boards, and you don't see anything about an ESP8266 or VMOS D1 Mini. We need to install them. And the first thing to do that is by telling the Arduino IDE where these tools are located, where it can find them. So I'm going back to the tutorial, and in step 3, it tells you a certain link that you will have to copy. And then in the Arduino IDE, you have to go to File, Preferences, and then here under Additional Boards Manager URLs, click on the little icon to the right, and then Control V to paste the link you just copied. If you have multiple URLs in here because you run a couple of projects, then you can just add more URLs line by line. But I only have that one link, so I'm just going to click OK and then save the settings by clicking OK. And now we've added those tools, but we haven't actually installed them yet. So to do that, we go to Tools, Board, Board Manager, and now it's downloading a list of all the available tools. And once that's done, we can type Deauther in the search bar here, press enter, and this should give us the Deauther ESP8266 boards by Spacemoon Technologies. That's the package we need because this is specifically for the project we are trying to install here. And so I'm just going to click install. Okay, once it's installed, I can close this. And if everything worked, we should now be able to go to Tools, Board, and see Deauther ESP8266 boards appear in the list. And now I can select the Lowland VMOS D1 Mini because that's the board I am using here. So I click that, and now if I go back to Tools once again, I see that a few options just popped up. For example, we can change the upload speed. So if you have troubles uploading the code to the board, you can try lowering this, for example, to 1150-200. That should always work. You can change the flash size. 1 megabyte is a good choice if you're just unsure about the memory that your board has. So you can just leave that there. Erase flash is a good option if you try to overwrite a previous firmware that might have kept a few settings alive and could mess with the new installation. So for example, you can select Sketch plus Wi-Fi settings, so it would overwrite the code, but also previous Wi-Fi configurations like SSIDs or known networks. And then we have the Deauther config. This is specifically for this project, and we can select VMOS D1 Mini here to basically indicate that we are running this on the bare dev board, or we can select one of the display examples. And to explain that, I have to go back. So in the wiki, we actually see a section called Setup Display and Buttons. And here you find a tutorial about setting up these little OLED displays to use them with the Deauther firmware. And you see a few example setups here telling you which pins to connect. And if you want to recreate that exact setup like here, you can now select the corresponding config here, so the display and buttons will actually work. But since we are running this on the bare VMOS board, we don't need that, we don't need the display, and so I just keep it as it is. So if everything is set up properly, we should now be able to click the verify button in the top left, and this will actually start the compiler. Okay, so this is what we like to see. There's no error, it says done compiling. Quick tip, if you want to see more information about the compilation process, you can go to File, Preferences, and show verbose output during compilation. And if you want, you can also enable compiler warnings here. But okay, if you didn't run into any problems, then we can continue by connecting the board. So I'm going to connect this to the computer now. Windows made a little connection sound, so I know it recognized the device. And if I go to tools, I now have a port show up here. I don't have any other COM port available, so I can be sure this is the board that I just connected. If you don't see a new COM port pop up, then check the cable. Some cables are power only. Those are usually used for phone chargers, for example. So they don't transmit any data, and so your computer cannot actually talk to this board. So on the wiki tutorial below compiling using Arduino IDE, you actually have a section called Installation Tips and Tricks. So that's where you find some good information. And this is also where you can find links to the drivers. So if you can't find the COM port, if your computer doesn't recognize the board when you plug it in, maybe you need to install one of those two drivers. Those are the most commonly used chips for these ESP8266 development boards. And yeah, make sure that you have them installed if your system doesn't recognize them by default. Now, if you have multiple COM ports available, so for example, here I have COM4 and COM5, and I don't know which one of those is the development board I have connected, I can just disconnect it, check the list again, and I see that COM4 disappeared. And now just to double check, I'm going to plug that back in. And I see that COM4 reappeared. So I know COM4 is this board in particular. In Windows, you can also open the device manager and look at ports COM and LPT, and maybe you can find additional information on the COM ports available. For example, COM5 is just some ordinary USB serial port apparently, and COM4 tells us the serial chip that is being used here, and it's using the CP210X driver. And I also know that the drivers are properly installed for this device. But if you successfully connected your board, select the COM port, and then we can click the upload button in the top left. This will start the compiler, and now we can actually see the verbose output we enabled earlier, and now it is actually uploading. So here we see the progress, pretty interesting. This is what we like to see. That's it, done uploading. So how do we check if that works? Well, we can check if the pawned network shows up in our network list, because that's a network the Deauther creates. What we can also do is go to Tools, Serial Monitor, and now make sure to select 115200 baud, and then type something like help, for example, and you should see an output like this. So if that works, then you have successfully installed the ESP8266 Deauther V3, and you are now able to use it. Now, since we have already set up Arduino IDE here, and I have made a few tutorials on the Deauther V3 already, I want to show you how to install that as well. So we go back to our repository here, and in the top left here, you can select different branches. So by default, this is V2, and that's the version we just installed. But I want to show you how to install the version 3. And for that, we have to switch to that branch. And now you see it also has a different README with a few infos. You cannot connect to it using a web interface, and you cannot use a display. That's very important to note. However, this version has a lot more complex features and attacks you can run with it. To learn more about that, check the other videos we did on the Deauther V3. So yeah, how do we install this? Well, first of all, you can also scroll down and it will tell you how to install using the bin file, the Arduino IDE, and even Arduino CLI, which is pretty cool. We are interested in installing using Arduino IDE, and you will notice that they basically share the same steps to set it up. So I'm going to click here to download the source code. So now I have ESP Deauther-3.zip, and I'm going to extract that, open the folder, open ESP8266_Deauther, and open the INO file here. Now I am in Arduino, and you can see that the code looks a bit different, but compiling and uploading this is pretty much the same. We go to Tools, select our board. Maybe you notice that there is no Deauther Andromeda listed here, but don't worry, if you have one, you can just select D1 Mini as well. It doesn't make any difference in this case. We can also leave all the other configurations as they are. For example, the Deauther config is made for the Deauther V2, and so changing this does not make any difference when compiling the Deauther V3 firmware. But anyway, we select our COM port, then we just click upload. Now, once it's done uploading, we go to Tools, Serial Monitor, make sure it's set to the right baud rate, and type help, and we should see a bunch of commands. You can also type chicken to see a beautiful ASCII chicken. If we type welcome, then we see it's version 3.0 dev. But yeah, this is pretty much the entire setup process. And if this video helped you set up your Deauther, let us know in the comments, leave a like and subscribe for more upcoming videos. And yeah, have a nice day.